Alright class, today we're going to be talking about line of best fit. And before we even start looking at some of these, what we're going to do in our calculator, let's look at these three graphs. So we're going to try to figure out what type of correlation do each of these scatter plots have, and it's either positive, negative, or none. What we're going to be looking for is actually a line that can best describe the point. So I'm actually going to skip the first one, and you'll see why in a second. But for the second one, notice how I have a scatter plot, and if I were to sketch a line, that's like a line that best describes that information. This is a negative slope, so this has a negative correlation. A negative correlation would be like the more time you spend, I don't know, playing video games, your grade, like the lower your grade will be. So like something is increasing, but also the result is decreasing as well. For the third graph, if I were to make a line, it'll look like that. That is a positive slope. So a positive slope is a positive correlation. It all depends on the slope. Notice on the first one, I can't really say that there is a correlation there because they're all scattered everywhere. So there's actually none. So this is the first graph, which is this one. This is the second graph, which is number 2. And my third graph. Oh, how did it go? There you go. Okay. So let's look at what some of the problems we're going to be expected to look at. A line of best fit is a straight line that shows the correlation between the two sets of data. You're going to use LinReg in your calculator, and I'll explain what that is in a second. Alright, so that's the graph. Notice that there's that blue line that is supposed to resemble the what the best line for the given information. Let's look here. Number 1. You're going to find the line of best fit using the data in the table below. So you notice how there is this table here. We're actually going to be plugging that into our equation. Now all of these steps are given to you right here, but I'm actually going to pull up my calculator and show you those steps as we go along. So let me make this smaller. Okay. Let's see. So first step is you want to press the stat key on your calculator. That stat key is right below the delete sign. So I'm going to click on that, and I'm going to have this on my screen. My directions say to select the edit button. The edit button is the first one, so I'm just going to press enter. And now it says to list in L1, the first column, list the X values, and then L2 list the Y values. So that's exactly what I'm going to do. That 1, I'm going to plug in to the left column. Then I'm going to plug 2. When you're doing this, you can press enter to move on to the bottom. Oops. Try to do too much here. 3, enter, 4, 5, 6. Okay. And I'm going to take care of my Y situation here. Make sure that you're lining up your Y values with the correct X values. And there we go. Oops. Got 1. There we go. So I've input these. Basically what I'm going to do is have my calculator tell me what the equation is, like what the slope is and the y-intercept. So then you want to select the second key and then the quit key. So second and quit. We want to go back home. From here, you're going to click your stat button again. And now we want the calculator to actually calculate this equation for us. So in order for me to get to this tab, I'm going to right click or click that right button so that I get a list of all this stuff. Now, in the first, if you looked at the notes before, it said that we were going to use LinReg. Where did I see that? I saw it somewhere. Well, we're going to use the linear regression. So going back to my calculator, I want to look at number 4, LinReg, because I want something that gives me the slope and the y-intercept. That's what the slope-intercept form gave us a line. So I'm going to go down to number 4, press enter, and press enter again. There is my A and my B. Now, in this calculator, they don't use M for slope, they use A, and B, we already know that's our y-intercept. So we can actually just use these numbers to create our own equation. So this is what we're going to do. I'm going to write y equals, my slope for the given problem was 1.7714. Okay, so I'm only going to use up to the hundredths place, so 1.77 x, and my y-intercept is 0.1333. So I'm just going to write plus 0.13. Okay, so that is the line of best fit. So if I were to actually plot this on the graph, this is the equation of the line. Now you might be given a question that says what will be the value of y if the x value is 14. We have to use this formula in order to figure that out. Well, I know my x value is 14, so x equals 14. All I have to do is plug that 14 into my equation in here to solve for y. So that's what I'm going to do. Y equals 1.77 parentheses 14. And then I'm going to use my calculator. You can use your own. I'm going to use my handheld one. 14, I get 24.78 plus 0.13. So my answer is 24 and 91 hundredths. That is the missing value. So if I were to go all the way down here to 14, my y value should be 24, approximately 24 and 91 hundredths. So it's just an approximation. So that's basically the directions when you're solving an equation. You can always look back to this video to see how you can use the calculator so that it can give you the line of best fit. Later in the year, we're going to be talking about curve of best fit, but this will be a great time to look at the following problems, and there's obviously problems in the back that deal with line of best fit. Okay, see you guys later. Bye.